Okay, so this is just to remind you of the colours and the numbers of the pH scale as we look today at the differences of how we can identify acids and alkalis. So we're going to use universal indicator paper, we're going to use red and blue litmus paper, and we're going to use a electronic pH meter. Okay, so what I've got here is a selection of different substances that we're going to use to test the pH of them. And we've got three things we're going to use to test them. So we're going to use red and blue litmus paper, we're going to use universal indicator paper, and then we're going to use this. This is our pH meter that's connected to the iPad, and at the minute I just have it in some distilled water. So you see it has a pH of 7. So I want you to have a guess what these pHs are going to be. I'm going to add them to the little beakers. So the first one, we've got lemon juice. So think back to the pH scale that I showed you at the very start of this video and have a prediction for a number. We've got some lime water, we've got some hydrochloric acid, we've got some ammonia. Some of you might remember smelling this when you were near it. We've got some ethanoic acid or vinegar, and then we've got some toothpaste. So think about what we use toothpaste for and what it could be. Might need to add some water to that to make more of like a solution up. So I'm just going to use one of the droppers to stir the water to make like a toothpaste solution. Now, I also have a couple of other things that I've just gone to get just a curiosity really to see. So I'm going to put some nail varnish remover into this one. I'm going to put it just here, you maybe just outside, and we're going to put some Diet Coke into this one. Now the Diet Coke may not work very well because it's a coloured liquid, but we'll give it a go and we'll set it here. So let's see how these work. So maybe you remember using red or blue litmus paper. Maybe you talked about it in primary school, or maybe when you were in year 8 you had a look at it. So red and blue litmus paper, you need to use them together. So when they're placed into an acid, it will turn red, and when it's placed into an alkali, it will turn blue. So how I remember this for litmus is I remember that acid is red and they both end in a D, and then alkali is blue and they both have L as a second letter. So both the red and blue litmus will turn red if they're in an acid, and they will both turn blue if they're in an alkali. So let's start off with one that we think we know already. So if we start with hydrochloric acid, which is here, what do you think should happen when I put both of them in? So both of them turned red in hydrochloric acid. And let's pick one that we know is an alkali. So we know that ammonia is an alkali, so let's put them both into ammonia, and they both turn blue when they're in that. Now, the disadvantages, so I suppose the advantages are it's easy to see whether something is an acid or alkali. You just put the piece of paper in and it changes colour. You don't need to think about it. It's just either red or blue. The disadvantage though, what happens if we have a difference between, say, a weak acid and a strong acid? Can they tell the difference? So let's compare them. We know that we can put our lemon juice on our pancakes, or that we can put our ethanoic acid on our chips. We know they're both weak acids. If I test the litmus paper with both of those, we should see that they both turn red, and they do. But when we compare the litmus paper test with the hydrochloric acid and the lemon juice, so this was our results for our lemon juice, and this is our results for our hydrochloric acid. Can you see they're both the same? So we can't use litmus paper to tell us whether things are a strong acid or a weak acid. It's no use for that. Let me just show you what happens when we put litmus paper into something that's neutral. So if we put litmus paper into our water, so can you see the red stays red and the blue stays blue. So that's what happens when we put it into something neutral. Okay, so let's have a look at a universal indicator. Hopefully you've used these before, or if you haven't used it in the paper form, you've maybe used it in the liquid form. So both of them works the same way. And inside the little packet of the universal indicator, we've got a color code. So we've got the little strips of paper, and then we've got our pH scale, just like the one I showed you at the start of the video. So if we use some of the papers, the advantage of the universal indicator is that we can tell whether it's a strong or weak acid. We can tell the pH. So if we look at our lemon juice, it's gone orange, it's around a pH 3. If we line it up with what color it matches, so pH 3 for the orange juice. For the lime water, it's gone a dark blue, around 12 I reckon. For the hydrochloric acid, we've got a red colour, so see it matches the pH 1. For the next one, what's this, ammonia? So ammonia is like a greeny blue colour, so we've got around pH 9 here. You see it lined up with 9. Okay, our next one then, ethanoic acid. Hopefully these are matching your guesses. Again, it's gone sort of a greeny colour around pH 3. And let's see our toothpaste. So do we realise that toothpaste is used to neutralise the acid in our mouth? So the toothpaste is gone around pH 8, just over 7 or 8. We'll test it with the digital one in a second. Now, let's see the two mystery ones. So the nail varnish remover, what's your prediction for this one? Oh, I think it looks pretty neutral. Okay, it's in around 6 or 7. And I'm not sure how the Coke's going to work. Oh, it did work. So there we go, it's around pH 3, maybe 4, maybe closer to 4. So universal indicator paper is better than litmus paper because we can just use one piece of paper and it will tell us the pH of the solution, whether it's a strong acid or a weak acid, or strong alkali or weak alkali. And of course the one I forgot to do with the universal indicator paper was the water. So when we put it into water, it stays green because it's neutral. So let's try it with the pH probe, the pH meter on the iPad. It's much better to use this than it is the others because we get a definite and an exact value for our pH. You can see here it reads to 1 decimal point. Obviously the disadvantage of this is that it's more expensive than buying a box of pH paper. So I'm going to use the wash bottle just to rinse it out each time. So if I put it into the lemon juice and give it a stir, you can see the pH change on the iPad. It's reading 2.4. So I'd said it was in around 2 or 3. I think I'd said it was closer to 3. So actually it's closer to 2 when we use the pH meter. Just going to use this beaker as my little sort of rinsing thing because the sink's out of the reach of the camera. Okay, then we're going to put it into this one, which is the lime water. So have a look on the iPad, 11.9. I think I'd said that was 12, so that was pretty good. The pH universal indicator paper worked well for that. Again, give it a wee rinse off. Okay, put it into this one, which is hydrochloric acid. So it's gone down 1.2. The next one is ammonia, pH 9. And the next one is ethanoic acid. I'm just going to move this to the other side. So ethanoic acid is like the vinegar for your chips, 2.3. I'm going to leave the toothpaste to the end because it's going to be hard to clean off it. So let's try the Diet Coke. pH 3, okay, that's why it's important to clean your teeth after drinking fizzy drinks. Okay, and then the other mystery one was our nail varnish remover. pH 5 for it. Okay, I'm going to see if we can get the toothpaste to test first. I'm going to put that into the water again. I'm going to add a wee bit more water. Just putting this in just really to clean it. So I'm going to add a wee bit more water to the toothpaste, just to try and make it alright. So let's see what this looks like. So we're above 7. It's gradually going up. Toothpaste should be slightly alkaline so that it neutralizes any acid that we have in our mouth. So after we drink the Diet Coke that's pH 3, then we can brush our teeth with our toothpaste, which is slightly alkaline, that will neutralize it. Now the important thing to realize is that it can't be like sort of 9 or 10. Your toothpaste won't be 9 or 10 because we don't want to cause damage to our gums or to our skin whenever we're using it. So hopefully you can answer the question in your books about comparing the ways that we can measure pH from using this video.